So today we're going to be talking about section 8.5, which is on variation functions. So what is a variation function? Well, there's lots of different variations, and we've looked at some of them, but maybe you haven't called them these things. One of which is called direct variation, and that was like back when we did um, line problems when you just had a slope and no intercept. These were called direct variation problems. And so an example would be like y equals 2x. 2 is your slope, and your y-intercept is nothing, so it would just be 0, right? But if you look right here, we called the slope a constant of variation, just a different name for it. So throughout your notes, I want you to make note of all of these right here that all have special names. And when it comes time to take your test, you're going to want to know all of these equations. Okay, so direct variation is the equation y equals k times x, where k is some constant of variation. Okay, now let's look at a problem. It's kind of interesting. It says if y varies directly with x, meaning we're using this equation, y equals kx, and y equals 15 when x equals negative 5, find y when x equals 7. Okay, so there's lots of different ways to do it, and if you look online, there's lots of different ways people teach you how to do it. I'll show you the way that I think makes the most sense to me. So it says when y equals 15, x equals negative 5. So we don't know our k, but something times negative 5 equals 15. So to figure out what k is, we divide by negative 5, divide by negative 5, and we find that k is equal to negative 3, right? And now it says find y when x equals 7. So we said that y equals k times x, and we know that k is negative 3, and we know x is 7. So if we want to find y, it's equal to negative 3 times 7, which would be negative 21. So what's the value of y? It's negative 21. Okay, here's a guided practice problem that I would like you to try now. Now, another one we call is called joint variation. Now, why do we call it joint variation? Well, it says y varies jointly as x and z if there's some k such that y equals k times x times z. So now instead of being y equals k times x, we also have a second variable z, and that's where our joint variation, because x and z are joint together. Okay, so they have an example. If y equals 5xz, x is 6, z is negative 2. What is y? It's negative 60. All right, let's look at an example. Example 2 says, suppose that y varies jointly as x and z. Find y when x equals 9 and z equals 2 if when y equals 20, so we'll set up our problem, x, z, when y equals 20, z equals 3 and x equals 5. So we don't know what k is, but we know that x equals 5, and we know that z equals 3, right? And so to simplify, we say 20 is equal to, well, 5 times 3 is 15 times k, right? Divide by 15, divide by 15. You find that k is equal to, well, if you reduce that, that's 4/3, right? So k is 4/3. So now it says find y when x is 9 and z is 2. So we'd say y is equal to, we know k is 4/3, we know that x is 9, and we know that y is 2. And so I multiply all those. Okay, remember, if you're multiplying fractions, you think of them over 1, right? So 4 times 9 is 36, times 2 is 72, over 3 times 1 is 3, and 72 over 3 turns into 24. So what's our value of y? It's 24. Okay, here's a guided practice problem, and it says, suppose r varies jointly as v and t. Find r when v is 2, t is 8, if when r is 70, v is 10 and 4. So you try that one now. Now, another one we have is something called inverse variation. And there's lots of applications of inverse variation. and some of them you've seen before in science especially. But inverse variation looks like this. It says you can either say xy equals some constant k, or you can say y is equal to k over x. And there's, like I said, there's lots of different examples and applications in the real world of inverse variation. Okay, so it says if A varies inversely with B and A is 28 when B is negative 2, find A when B is negative 10. So what I'm going to do is I'm going to say this, okay? When A is 28, B is negative 2. So I'm going to say, well, if we go back to the problem, it says this, that x times y equals some k. So that's what we're going to say. So instead of x's and y's, we use a and b. So a times b equals some k, right? And so we know that a is 28 and b is negative 2, and then we have k, right? Well, 28 times negative 2 is negative 56. So that's what our k is equal to. And that helps us in the next part. When it says, you can do two different ways, but I think the easiest way is just to say this, that a times b, which is negative 10, has to equal negative 56, because that's what k is, right? So you divide by negative 10, divide by negative 10, and you get a is equal to 5.6. Or the other way that they said to do it was this. They said that y is equal to k over x, right? And so you could say that we know that b, in our case, negative 10, is equal to negative 56 over x. It's the same idea. You cross multiply, and you still end up getting 5.6. So it doesn't really matter which way you do it. You get the same answer both ways. So here's a guided practice problem that you can try as well. It says when x is 24 and y is 4, find x when y is 12. Now, I told you that there's lots of applications for inverse functions, and here's one right here. It says the length of a violin string varies inversely with its frequency in its vibrations. If a violin string is 10 inches long and has a frequency of 512 cycles per second, find the frequency of an 8-inch violin string. So if we think of this, right, we don't know what k is, but we know x and y. So if x is equal to our length, right, and y is equal to our frequency, okay, we can do this. We can say, well, 10 inches, 512, so 10 times 512 is going to equal our k, right? Which in our case would be 5,120. So k in our case is going to be 5,120. And now it says find the frequency of an 8-inch violin string. So we're going to say 8 times our frequency, call that y, has to equal 5,120. And so we divide by 8. We divide by 8, and I'm not entirely sure what that is. But I do know that Desmos can help me find it. Or I guess we can use a calculator. So 5,120 divided by 8. And that equals 640. So we know that our y in this case is going to equal 640, and then it was cycles per second. We'll just leave it at 640. Okay, so the same thing can happen. We just use our inverse variation to find out what our y value is. Here's a guided practice problem that has to do with the distance of an object from, in this case, it says Earth is 93 miles from the sun. Jupiter is about 483.6 miles from the sun. Find how many times larger the diameter of the sun would appear as the Earth on Earth as on Jupiter. All right, another one we have is something called combined variation. All right, so combined variation is this, okay? So here is our combined variation. It's set up a little bit differently. It's like the combination of both direct variation and inverse variation. And so we have this right here. So this is something that you should for sure have next to combined variation in your notes. So it says y1 z1 over x1 is equal to y2 z2 over x2. Okay, so we're going to use that, and obviously we're not going to use x's and y's in this example, f's and g's, but it's a very similar setup. Okay, and it says, suppose that f varies directly as g and varies inversely with h. So in our case, it's going to be like this. So it's going to be f g over h. Okay, it says find g when f is 18 and h is negative 3, if g is 24 when h is 2 and f is 6. Okay, so we don't know g in one of our examples. So I was going to say f is 18. So 18, we don't know g, over negative 3 is equal to, g is 24, right? We know that f is 6, and then the bottom, h is 2, right? So all we're going to do is we're just going to solve what we can. So in this case, 18 divided by negative 3 is negative 6g. And then 6 times 24 divided by 2. Well, 6 divided by 2 is just 3. And 3 times 24 is going to be 72. So now we have negative 6g equals 72. And we can divide by negative 6, divide by negative 6, and we find that g is equal to negative 12. And there's our answer right there. Okay? Here's a guided practice problem that you can try. Hopefully you understand. Like I said, the best case for you to do and the best examples for you is to make sure you have your notes handy so you can see what the equations are as they come. Good luck, and let me know if you have any questions.